Welcome, everyone. I'd like to welcome everybody, prospective students, old students, and current students, faculty, and everybody. You're here for the seminar in computation science. I am Pavlos Protopappas. I am the scientific program director for the Institute for Applied Computation Science, which runs these seminars. Our seminars are about bi-weekly, and they focus on computational aspects, topics of computational science. That includes from biology to physics to astrophysics to social media. So before I introduce our speaker, I would like to remind you of upcoming seminars. The next one is on April 1st by Terry Yu, one of our visitors. He's going to be talking about challenging the canon, what happens between biomedicine and computing. This is going to be a very exciting talk. Followed by Alan Heaven, cosmologist from Imperial College. He will be talking about hierarchical Bayesian models for 10,000 parameters modeling the cosmos. Finally is Verena, so one of our faculty lecturers here. She will be talking about mapping the brain. So this is what's going to be happening the next 3 seminars. Today I would like to introduce our speaker, Rayid Ghani. He is at the faculty at the University of Chicago. He has quite a few titles: Director of Data Science for Public Policy. He's a Chief Data Scientist for Urban Center on Computation and Data. And he also has EdgeFlip. Not anymore, okay. But he worked at the Obama campaign in 2012. So that's how he started that. He studied at CMU, machine learning, with Tom Mitchell. For some of you may know the book by Tom. And he's undergrad at the University of South in computer science and mathematics. His interest is using machine learning and data mining for social impact and social good. So it's one of the topics of our seminar. It's not only about science, and not about natural science, physical science, but also how to use data science, make our lives better. Only thing about is not allowed to recruit our students. Just a warning. So today, Rayid will be doing practical data science for social impact. And please help me to welcome him.
Thanks. Can you guys hear me okay in the back? Somebody, okay. Thank you, Pavlos. So this actually is a recruiting talk. This is the perfect week to recruit people, right? Because a lot of you hopefully are coming from somewhere else and you're thinking about coming here. But no, seriously, it is a recruiting talk because my goal is really to recruit people to do more of the type of work I'm going to talk about. So I don't care where you do it, when you do it, how you do it, how often you do it, why you do it, just do it. So I don't work for Nike, so basically this talk is going to be about a lot of buzzwords and data science, social good, public policy. Nobody knows what that means. I teach in the public policy school. I don't know what public policy means. But I thought what I would do is sort of start by depressing you guys and give you a few depressing stories. Depressing story number 1. We've all read about this. We've seen videos, police misconduct, police violence, police brutality. It's a big issue in the US right now. It's a big issue in a lot of countries, but it's becoming a bigger issue in the US recently. And a lot of these stories we hear, it seems like all of that is preventable. There's sort of 2 kinds of misconduct that happens. There are people who are inherently bad in some way, but then the majority of it, it turns out, is not people who are bad. It's just people who are under different circumstances. They don't get the support they need. For example, every police department right now has a system, not every, pretty much every police department, called early intervention system. And what that system is supposed to do is raise a flag when it thinks a police officer is likely to do one of these things. So how does that work? Well, a bunch of people sit around a table and decide what are those indicators. So they take an indicator like if somebody has had 3 complaints against them in the last 90 days, raise a flag. Somebody else said, well, what about if they've used a lot of force in different arrests? Like, oh yeah, that's a good idea too. So how about if they've had 6 uses of force in the past 180 days, raise a flag. So what about if they just miss work a lot? Maybe that's an indicator. Yeah, that's a good idea. So let's add that. So what if they had like 5 sick days in the past 120 days? And so they come up with 5 or 6 of these. They put them into the system, and then the system goes on and it keeps raising these flags. Clearly, we can all sort of tell that type of system doesn't work. It doesn't work because often the indicators that are being used are really not something that you can use to prevent these things, right? It's often too late. If they've done 6 stupid things, 6 horrible things, it's too late to prevent that anymore. You're basically going to fire them. So instead of an intervention system, it becomes a punitive system. The second one is too late. It's not doing anything early. The third one, which is interesting, what police departments actually tell us, is that it turns out that system is too transparent. You can pretty easily game the system, because if you've had 5 of those and it's been 150 days, common sense tells you, oh, wait, be a little bit careful for the next couple of weeks. And it turns out that does happen. So there is clearly scope for a better system, except no police department today is using that system. And a lot of these things that are happening, a lot of the violence, a lot of the misconduct, is preventable. So I'll come back to that and tell you some of the work we're doing. So depressing story number 1. Depressing story number 2, this is from Chicago. So there is a thing called lead. It's often recently we've heard about it in Flint because of the lead pipes and water. But lead has been an issue for a long, long time. So every home that's built before about 1977 has lead paint in there. And lead paint is fine if it stays inside the walls. But as homes get old, paint starts crumbling, dust starts coming off. And as kids start crawling, they pick up lead paint, they put it in their mouth, it goes into your bloodstream. And once it's in your bloodstream, it basically starts getting used as calcium, so it starts coming out later. And it has a lot of horrible effects, side effects. IQ issues, motor control, memory issues, brain damage. And the worst thing of all is that this is all irreversible. Once you have lead poisoning, there's nothing you can do to take care of these effects. Once you're exposed, that's it. So how do cities deal with that today? Well, most cities get kids tested at some age. If the kid turns out to be blood tested, if it has high blood levels, then they get reported to the public health department. The public health department goes and inspects their home for lead, and most likely finds lead in there, because how else did the kid get poisoned? They fix the lead, and then they go back and pat themselves on their back. So the policy we use today is we use kids as sensors to detect lead in homes. We then go home to their homes and verify that sensor. And it turns out it's a pretty accurate sensor, because once you have lead, these things happen. So I'm not trying to be funny, but it's a pretty horrible policy. We all see that. They can do better. And again, I'll give you some work that deals with that issue. But it's a pretty common issue right now. So depressing story number 3. This is work with, there's sort of a large nonprofit called Nurse Family Partnership. They have a program that pairs up nurses with expecting mothers to help them with pregnancy, typically their first-time teen single mothers. It helps them kind of go through the pregnancy as well as the first year of the kid so that they can have good economic and health outcomes. It turns out most of the moms, well, actually not most, probably about 40% of the moms that come into the program end up leaving before the program is over. And that's not just true of this program. There are a lot of these social services programs where the biggest challenge they deal with is a person who comes to them doesn't come back after the second time or the third time. Same thing happens in a lot of HIV programs, where every city has HIV diagnosis. If you get diagnosed with HIV, they enroll you into this program, except a large number, 40% of people, again, there about 45%, drop out of that program. And what do? They try to call the phone number, they try to probably send them mail, they may even try to visit their home if they have an address, and most of the times they don't find them, because most people don't really give you accurate phone numbers, they don't have landline phones, and they move around quite a bit. So, another story. Another depressing story. More than about 30% of kids in the US drop out of high school. And this happens all the way through high school, right? It's 9th grade, 10th grade, 11th grade. And at the same time, we hear about all these after-school support programs that are keeping kids in school. It turns out most of those programs are not targeted to the kids who are at risk of dropping out, because mostly those programs are opt-in programs where typically a parent has to go and do something to sign up for these programs, and that's already a big sort of selection bias in who's going to go and sign up for these programs. Another story, this is EPA, but it's not just typical to EPA. They have about 500,000 facilities that they need to inspect over time for different kinds of violations of environmental waste. So this is one particular type of waste, but there's about 500,000 facilities in the country that produce some sort of environmental waste. And they have to comply with a lot of different criteria. It turns out organizations like EPA only have a very small budget for, right now they at least have a budget, maybe next year they won't have a budget. But for now they have a budget of about inspecting a few thousand facilities a year. Their goal is to deter anybody from violating those criteria, except their resources are, they can only inspect about a couple of thousand of those. And today they mostly do it fairly randomly. And so it turns out over half of the facilities they inspect don't end up having any violations, so they're really wasting those efforts. So these are kind of some examples, but over the sort of the past few years, sort of a larger list of organizations that have very similar problems. So schools that have issues with kids dropping out of school, not making it to college, not graduating from college. Even so, right now we're talking to an organization which is in Tulsa, where Tulsa has this universal pre-K program. And it turns out what they've found is that that program basically closes the achievement gap between sort of the rich and the poor, between minorities and non-minorities. But as soon as they get to 2nd grade, 3rd grade, 4th grade, that gap starts increasing because they don't have that program in place. So schools, similar problems. Hospitals, same type of problems. They're dealing with resource constraints, early warning problems. Public health departments, energy organizations, nonprofits. So this is a fairly, all the kind of the 4 or 5 problems I was talking about earlier, those are problems that are fairly common across the board, across most government agencies, across most nonprofits. The one thing common among all of them is we can do something about it with data. Now, the data is not the answer, it's a piece of the answer, but there is a very concrete thing you can do that helps them do much, 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 much better. So what I'm going to do is kind of abstract a little bit back and kind of give you guys, what are the types of problems that we can create templates of that I talked about earlier, right? So first problem we talked about, well, one of the problems was, can I detect who's going to get lead poisoning early, right? So in that case, right now, we test kids, we find they have high blood lead levels, and then we go inspect their homes. What if we could just predict what these kids are going to be who are going to get lead poisoning? What if we, instead of testing them after they get lead poisoning, let's see if we can predict who they're going to be, and then go inspect their home preemptively so that we can prevent that from happening. And that's kind of, so this is some work we've been doing for the past almost a year and a half, where we started with getting about 15 years of that data for all kids who were in Chicago tested for blood, as well as all the inspections. And what we were able to do was predict which kids are going to get lead poisoning and then start doing preventative inspections. Even more importantly, what we sort of really are going for there, which is going to happen in the next 6 months, we just started working on that, is working with hospital systems to do that before the kid is born. So when somebody is pregnant and they get to the hospital, we can predict at that point that the kid who's going to be born is going to get lead poisoning based on who they are, based on where they live. Let's send the inspectors in early and fix those hazards before the kid is born, so that the hazard is not even there when the kid is born. But if you think about this, the more generalized problem here is, I'm doing early detection. I'm basically building early warning systems for all sorts of things. Same is the example with the police departments, right? So right now, the police departments, the systems they have, they're not early warning, and they're not really preventative. They don't really help you prevent things. So what we started working with about a year ago with one specific department in the beginning, which is Charlotte, North Carolina, is we took their existing system, and for the first time, I just said, well, let's see if it even works. And before we say it doesn't work, let's validate that. So we got, again, data for about 10 years from the police department, everything they had. So everything about their officers, every investigation they've had about their officers, every arrest, citation, any dispatch, anything we knew. They gave us all of that data. That took a while and a lot of convincing. And then we kind of built these, first we evaluated their existing system, and it turns out their existing system was horrible. It was flagging about 50 to 60% of their officers for risk, which completely makes it useless, because if it's just flagging all these people, you can't take any action against these people. So people just started ignoring those systems. Even after flagging about, so they have about a couple thousand officers right now, even after flagging about half of them, 60% of them, it still only found 70-ish% of all the officers who ended up having one of these adverse incidents in the future. So not only was it raising a lot of false positives, it wasn't even finding all of them. So what we did was we took all that data, and again, the usual machine learning process, right? So we had all the data, they had already tagged officers as because they did something. We could build models that could predict who's going to be at risk and who's going to do one of these things in the next 3 months, 6 months, 9 months, 12 months. And it turns out even the first pass model was able to reduce the false positives by about 40-ish% and increase the number of people found by about 15 to 20%, right? And that was a few months of work. That's not something you spend years and years and years and years doing. It's a few months of work can go from, a system that's completely useless, a system that's slightly less useless. Now that's not the end, right? You still need to go start doing more things. So the first step, just like in the lead example, building the model is often sort of the easiest piece, right? Then you have to figure out, okay, how does that get used? And how does that change the actions those organizations take? So in the lead case, you start doing preventative inspections. Well, it's slightly different now, because before, they were being measured on efficiency. So if they inspected 100 places, pretty much all of them had lead hazards because of the really accurate sensor we had, the kids. Now that our sensors are less accurate, now we're using prediction, maybe only 30% of the inspections will be positive. Now the good thing is that each of those 30% is preventing something from happening as opposed to the old world, where the 100% are not really preventing anything, at least right now. In the future, they might. So we have to change the way their process works. Same for putting it into the hospital so you can start detecting things before the kid is even born. Now in the police case, the easy intervention is you start giving people training, you start giving people counseling. Right now, a lot of people who end up in these scenarios are dealing with people who are mentally unstable, and most police officers don't have that training. They don't have the training to deal with those people. And as we started looking at these models, it turns out, one of the big predictors that came out was number of suicide calls a police officer responded to recently, number of domestic abuse calls they responded to recently. And those are clearly signs of stress, right? They're under stress. And so that got us thinking, how about instead of sort of these large interventions, how about we start thinking of interventions almost at the dispatch level, right? So if you sort of know how the dispatch system works, right? A call comes in from 911 somewhere else, the police dispatcher has to decide who to send. And what they look at is who's nearby, and then pick the nearest person to send over. Now, what if we could predict the nearest person who's 2 minutes away has an 80% risk of having one of these adverse interactions in that incident? There's another officer 4 minutes away, only has 10% risk. Now the dispatcher can decide whether this call is really that urgent that you want to take the 2-minute person. If it's not that urgent, what if you send the 4-minute person over who has a much lower risk? Can we start being much more fine-grained in how the dispatch happens as opposed to large interventions? Can you start doing micro interventions that can reduce the risk at the same way as the larger ones would, right? So both of these examples are kind of this, can I detect something early, right? Same for the school early warning prediction. Who's going to drop out? Who's going to not make it to college? The second one we're talking about is, can I determine which facilities to inspect? Can I determine this? So the second example is with some work we're doing with City of Cincinnati, where Cincinnati, like many cities in the US, Detroit, Memphis, people are leaving. It's shrinking, there's a lot of blight. And one of the things Cincinnati wanted to do was to see, can I use inspections? So every city has these code inspectors, which most of us hate, right? Because they come in and say some silly, your roof is a little crooked, or you have this pole, depending on where you live, but it turns out what they wanted to do was to see, can I use these inspectors to do inspections in order to detect blight early. Because often the way these inspections are done is somebody calls about it. They complain that the windows have been broken in the house next to me for 3 weeks. The garbage hasn't been picked up. There's a bunch of crap outside. Can you come and look at this? And they send some inspectors over. And most of these, turns out these inspections are too late. By that time, the area in the home is typically abandoned and it's already blighted. So what they wanted to do is see, hey, can we be much more proactive in inspecting homes that are eventually going to become blighted, so we can start preventing that from happening. And it's a very similar problem to sort of the EPA problem of, can I predict which facilities are likely to be violations and then start sending my inspectors over there. But that's a very generic problem. It's a typical resource allocation problem where I've got a bunch of things, I can only do something about these, which ones should they be? So fairly standard problem, right? The third one, turns out, is a fairly common problem as well, but a lot of organizations, again, nonprofits, governments, they have a goal that they need to achieve, right? So this last one, this one here about how do I improve maternal mortality was a project we did about a year something ago with the government of Mexico. And they were given a large number of these Millennium Development Goals by the UN, and one of them was reducing maternal mortality. They had met pretty much every other goal except that one. And they came to us and said, look, we've been trying to reduce this number, we just can't get it to a lower, the threshold that we're asked to. And we don't know why. Can you help us figure out what policies, here are the policies we have access to, which ones do we use? And so what we did was we looked at their data and basically came up with what we're calling like causal hypotheses, right? We don't really know exactly which policy is going to improve it, but can we narrow it down to a small number of things that we can then test actively? And it turns out a couple of things we found were obvious in hindsight, but they weren't, we couldn't have narrowed it down to those 2 or 3 initially. Everything would have been obvious, but we wouldn't have known which 2 or 3 of those 20 obvious things we should try to fix. So it turns out a couple of them were, how often do they go to the doctor while they're pregnant? And it turns out a lot of them were missing their appointments for different reasons. Transportation reasons, they just didn't care, they didn't remember, something else came up, they were busy. So what the government of Mexico did is they used that to then design a pilot with UNICEF to give these mothers, expecting mothers, cell phones. And they used cell phones to then send them messages as reminders to go to the doctor, and if you're going, let us know if you went. If you can't go, tell us why so we can reschedule. And that pilot is running right now, so I don't know the results, but we'll find out what the impact of that was. But again, that's a fairly common problem where I'm an organization, I need to improve some outcome. I have access to a lot of different policies. For example, last year we worked with another organization in Mexico called Infonavit. Infonavit is basically kind of a semi-public, mostly half private public mortgage company in Mexico. And they have a very high, so they basically give mortgages to low-income people in Mexico. They have a very high home abandonment rate. What happens is in Mexico is if you're employed, a part of your income goes directly into this fund. And then when you want to buy a house, you can borrow money through that fund and get a mortgage. So if you continue to be employed, you can't really not pay your mortgage. So your paycheck keeps going to them. But when people can't stay in that home for whatever reason, they end up abandoning the home and moving somewhere else. And that's clearly bad for the people. Now, if it was, Chase or B of A, you would say, well, let's not give mortgages to those people, right? Because that's sort of the metric there. Whereas if you're Infonavit, they have to give you a mortgage. They don't have a choice. So their goal is to reduce abandonment of these homes, which kind of aligns really nicely with the goals of the government. So we started working with them. Same thing is we looked at home abandonment and see what are the different factors that end up leading to home abandonment. Is it distance from transportation? Is it distance from their job? And what we ended up doing with them was to help them build a system where when somebody comes in and applies for a mortgage, we can start predicting, depending on if you get a home here versus here, your chances of abandoning it in the future are higher and lower here. So maybe instead of that home, you should think about these. Now, there's more depth in there. It's not always easy for somebody to say, okay, I'm not going to get a home here because it might be too expensive over here. But that's the kind of thinking that they were thinking about, is how do I take the data to come up with potential policies that I can change around giving loans, around creating more facilities, transit, hospitals, schools, because the government was able to do some of these things in those neighborhoods. So the last, second to last type of problem is, again, fairly typical, and that's the problem often when you talk to nonprofits about, hey, what can I help you with? That is the problem they'll often ask you about. Either it's fundraising, or it's, can you tell me how much impact I'm having? And what we end up trying to do is we often try to change that formulation to say, well, we don't really care how much impact you're having, but we can help you with how to increase your impact. The reason they care about this problem is because their funders are asking them about, I gave you X amount of money, tell me what you did so I can give you, so I can basically justify it to my boss that I spent this money well, right? So what they spend time doing is justifying their existing, not necessarily trying to improve what they're doing. So what we try to do is kind of shift this problem around and say, wonderful, we can help you with your how much impact you're having, but how about we really help you with how to increase your impact? And they're typically, it depends on sort of how much, I'll go a little bit deeper later, but that's another sort of problem type that happens in public policy and kind of working in social impact areas. And the last problem is some work we were doing last year where we're working with a lot of, so one of them was community colleges. And community colleges are more and more becoming the place where they're basically job training places, where somebody goes in to get trained for a job or to go to college, but more and more it's really, and a lot of community colleges we've talked to, they basically said, we have no idea what's going to be in demand 2, 3, 4 years from now. So we're designing curriculum, and that's actually also true for most other colleges. We're not predicting, here are the things that are going to be in demand, and they're going to be, if you're a job training program, we kind of guess what is going to be in demand, and we sort of train you for those skills. But community college is slightly more honest. They'll say, we really have no idea what's going to, we're coming up with these courses, and we're hoping that these people are going to go through this program and get employed, but we don't know. More importantly, there is no data out there that I can get. Here are the list of skills that are going to be in demand. Here are the list of skills by geography, right? Because a lot of these colleges are really training people who are going to be locally employed, whether it's Chicago or Boston or Cincinnati or Kansas. So there is no data source out there that tells you by skill, by geography, by time, what is the skills demand. There is no data set that gives you a list of skills that you should be training people for. It's such a messed up world. Well, the first thing they want to know is there even data for me? And it turns out there is no structured data, but there are lots of sources that are out there. Take Craigslist. The job postings on there, that's data. That's telling us what are people hiring for? What are they looking for? Take Career Builder, take Monster, take LinkedIn, even for different types of jobs. USA Jobs. There's a lot of these job posting places, and there are a lot of places where people are putting if they have a resume, and they have all this data, except it's not available, accessible in a way that a city college or a job training organization can take that and say, I can use this. So one of the things we've been doing is building these partnerships with LinkedIn and Career Builder and Craigslist and USA Jobs and working with Department of Labor to basically create kind of a localized real-time meaning, at least correct nearest year, 2 years, whatever the data is in this case, and come up with a skills taxonomy where these people, where these organizations can go and use that to make training decisions, to figure out how to match the people they have to the jobs they need, what the skills gap is, how to make all these decisions. Right now, nothing exists. So a lot of this is kind of using text data to try to extract skills and normalize those to figure out what's happening and can I predict what happens. But this problem is a recurring problem, right? So we worked with Feeding America, which is a large national nonprofit that basically helps food banks get excess food. And their problem was they said, look, we've done a really good job of finding which supermarkets have excess food capacity, where they have extra food, and we've made these arrangements so that they can donate all their foods to local food banks. Except it turns out that in the US, the meal gap, number of people who don't have meals, if all of the supermarkets they have relationships with gave away their food, it would still only shrink that gap by about 50–60%. So you still have a huge gap remaining. And their next goal was, well, restaurants, what if we talk to restaurants? What if we ask them to donate their food? especially the packaged foods, right? Not the cooked foods, because there are health concerns there. But they buy cans, and if they are close to expiry, they throw them away. So what if we talk to the restaurants? What they didn't know was, can we get a data set where for each restaurant in the country, we have some idea of how likely are they to have extra food? There was no data out there, right? And so we started looking at, well, what if we looked at something like Yelp and figured out, can we predict from the Yelp reviews how much extra food they're going to have? So why would somebody have extra food? Well, maybe because they're badly managed and they buy lots of extra food. Or if you've what's that show called? Kitchen Nightmares, right? With Gordon Ramsay. If you have a huge menu that you have to have too many things in the restaurant in order to make that menu, you're probably going to have extra food that you're wasting. If you're badly managed, you have a big menu, your demand is unpredictable, right? So if you look at Yelp reviews and sometimes there's a long line and sometimes there isn't a long line, that means your demand is fluctuating, and you're probably accounting for it by getting extra food that eventually ends up going to waste. I don't know. Those are all kind of hypotheses, right? But can we take the Yelp data and start predicting, giving scores to these restaurants, and then Feeding America was going to go to the food banks and say, let's start calling them. Let's start collecting data that validates some of these hypotheses and starts building a model that allows us to refine it. But the key was to give them the initial data in a structured form that they could start doing something with. So here are sort of the 5 templates of problems which basically span, pretty much every area around education, health, economic development, poverty, social services, criminal justice, disaster relief, all these things. And our goal is sort of see, can we create open source tools that can solve each of these 5 or 6 problems that these organizations can start from? It's not going to completely solve their problem, but can we start creating these templates and start sort of figuring out how do we build these, right? So when we're doing the early warning system, there's sort of, I'm not going to go into these because these are more sort of open questions right now, where if you just take a lot of off-the-shelf tools, even off-the-shelf algorithms from research, they don't quite answer a lot of these things for these problems. But I'm not going to go to that because it's going to sort of take a little bit longer than we have here. I'm happy to talk to you about it afterwards. But the only one I want to talk about here is the last one, which is if I can predict something early. So if I'm going to predict, here are the kids who are going to drop out of high school. How do I'm assuming that I have an intervention that works, that helps them, right? But that's really an assumption right now in most cases. If I can predict these accurately, I'm hoping that my intervention fixes them and reduces their risk. What if the ones that are predictable are also the same people who are not affected by that intervention? Because it turns out that a lot of the intervention in social science research is really done on sort of the average effect, right? So you take a bunch of kids, you apply an intervention to all of them, and you find 10% reduction in dropout rates. Wonderful, I know an intervention works now. So now let's figure out this other piece, predict who's at risk and apply the intervention. But there are very few, if any, research or work going on that's combining the two, that's saying, let me figure out how do I do prediction-driven interventions, and how do I match these two things, right? And often what I really want to do here is figure out, given an intervention, can I generate a ranked list of students who are most likely to be affected by this intervention? Because that's what I really care about. Ideally, I want to help all the students, but if my intervention isn't going to help a student, there's a good chance. I'll give you an example from my political days, right? So when I was doing work at the Obama 2012 campaign, imagine the same scenario there. Like, I need to persuade people in order to vote for us. Now, if I predicted you're not going to vote for me, which is the highest risk people, those are exactly the same people who I can't persuade because they're so set in their minds. And so I don't want to predict that the most at risk and then persuade them. I want to predict the most persuadable and persuade them. And here it's slightly different because over there my goal is to win, so I don't need to persuade everybody. I just persuade enough, 2%, and that's enough for me to win the election. Over here, I care a little bit more. I do want to persuade as many kids as possible, but this type of work allows us to kind of think about what interventions are working on what types of kids, and then design new interventions for the kids who we don't have anything existing. There's also the right kind of performance metric, which is a typical, but a sort of skip over here. Second problem, again, it's if I'm prioritizing, if I only have X number of resources, I have X inspections I can do, and I have a million places I can inspect. Which ones do I do? And there, one of the challenges becomes, how do I validate my results? Because when I typically work on machine learning and data science problems, I have this set, what I call the labeled data set, right? I've got inspected places, and then I hide some of those, and I predict on those and see how well it does. Except it turns out, most places are never inspected. So I'm basically validating on this biased set, and it turns out when we actually try that, you get horribly biased results. But that's what we all do, at least in most of the research world. So when you start deploying these things, there are a lot of new challenges that come around that are really tricky to deal with. And I'll talk about a little bit about that work later. Not much. And then I'm going to skip through some of these. I've talked about some of these problems. Impact. So I'm going to quickly mention, this is an important topic, right? So whenever we talk about data, some privacy security question comes up, right? And I sort of don't want to talk about that right now because it's a longer topic. What I do want to mention is when we start working with organizations that are dealing with people, and people not clicking on ads, but actual people whose lives we're affecting, it becomes really important that we know what's happening, right? Transparency is really important in these models. Ethics are really important. So let me give you an example of ethics, right? So typically, what we care about is we build a model, we predict its performance in some holdout set, and we say, hey, I'm 85% correct. Wonderful. What if the 15% you're wrong on is systematically wrong on certain types of people? So if you're giving loans to people, and you are wrong typically, let's say, because you don't have enough data from people of a certain type, let's say it's low SES, or it's African Americans, or it's minorities, or it's women, you're going to be more wrong on those people. And it's fine if you're Google and you predict this person's going to click on this ad and you're wrong because there's not much of a cost there. In this case, not giving loans systematically to people, you're basically hurting these people's lives. So you have to be very careful around, one, detecting any bias in your predictions, and then two, correcting that bias. And it's really important because one of the things we don't look at often is what is happening. We look at results, we look at what predictors or features are important, but we never really think about sort of how was my data collected, right? Often this data is collected under some process, and often that process is biased. So if you're a computer scientist, you don't care, you just get data. God gave me a matrix, I'm going to take my matrix and build my models and do ROC curves and move on with life. And often, more and more often, we're dealing with these problems that you just can't do that. You have to figure out how your data was biased. Even if you may not be able to correct for it, you should at least know what the bias is. And same goes for transparency, where transparency is sort of interesting, right? You want to be able to explain to people what it's doing, not necessarily because they care, but because you're trying to convince them to take an action. And if you can't convince them to take an action, the whole work is pointless. Now, if you remember the police example, that's one of the examples where transparency actually hurts you. Because the model was so transparent, the threshold-based system, 3 complaints and raise a flag, that somebody's able to game it. The same thing happened when we were working with some of the school districts, where they said, well, we can put the model, we don't want to put the model in front of the teachers, because if they figure out that the GPA is a predictor, and the teachers are being measured on how many kids in their class are at risk, one, that shouldn't be the measure, but given that in many schools it is, maybe they can change the GPA, they can just inflate the GPA, and that's going to affect the model results, and that becomes gameable. So often there's sort of this trade-off between transparency and gameability. And some of the things we're thinking about is how do we, can we just finish the sentence and then I can, how do we trade off, how do we sort of figure out building these models that are transparent, but making them really hard to game? Yeah.
I was going to say, if you're creating a system that has a certain accountability based upon these metrics, but you don't convey to the people that you're monitoring, let's use that word, what those metrics are and what the accountability is, then it becomes kind of kind of persecuting kind of situation.
Exactly.
I think about public school teachers. So you have metrics on them, and you're not letting them know what those metrics are. But then one day the principal comes to them and say, "Hey, you know, Sally or Jim, I need to talk to you," and it comes out of the blue and becomes, like I said, kind of persecute.
Absolutely. I mean, so this problem has been around in fraud detection systems for a long, long time, where there is an adversarial relationship. And in a lot of these cases, it's not an adversarial relationship. It's you're trying to do something good. In order to do that, you have to, you know, detect some of the bad things, but you want to make sure that the people who are being flagged know why they're being flagged. And so how do you make these systems how do you do this trade-off? I don't have any great answer. It's something that's an open question that we're thinking about, but that keeps coming up over and over again. So I want to sort of move, you know, since this is a recruiting talk, I want to sort of move towards, here are all these problems, right? So these are out there. They're all problems that most of us have some skills that we can use to help solve them. But it turns out that most individuals don't have all of the skills. So I want to talk a little bit about sort of what based on the work we've been doing the past few years, especially in sort of training students how to do this better, things we've learned about what we need to teach and some examples of sort of how we're doing that. Right? So here's what we think, this is, you know, a current working of the skills we need to have in people in order to solve these problems, right? You kind of have the obvious, you need to know how to program or do some coding at least to be a better human being. We all know that. You should be able to do some stats and machine learning. You should be able to, you know, do some social science, hopefully, so you can think about how to do causal inference and how to think about how some of these methods. You need to know how to deal with data. So databases, you need to be able to run experiments. The two things that we find that are really, you know, communication is critical, right? And not just communication at the end, the visualization type things that we think about, but how do we convince people to use what you're doing? Because that's often, you know, the beginning and the end of these projects is often the hardest piece, is how do you communicate to them why they should do this in the first place? Because a lot of organizations that are, you know, in this phase, they're sort of nonprofits and governments, they either think data is sort of, it's magic, right? You can use all these different tools and it just solves all your problems. Or they think it's only for large companies. It's only for Amazon and Google and Walmart, and it's not really for us because we're a tiny, small organization. And so they typically live in these two places, and they don't quite know what's doable. So you have to sort of figure out how to communicate to them the impact of what you want to do and how it can affect them. But once you've done it, you also have to communicate to them how to actually take it and use it every day. But I think the most sort of important thing is really the first piece, which we often don't teach in any courses, right? Often the problem comes pre-formulated. So take most of the assignments and even most of the real problems we deal with, they sort of come as pre-formulated problems. I need to detect this early. I need to predict this. I need to cluster these things. Whereas there's a bulk of the time in a problem, working with an organization, it's really, how do I formulate the problem? How do I make sense of what you're coming in with a vague goal? So a school comes and says, I want to improve education. Like, okay, wonderful, so do I. But let's break it down a little bit further. Okay, I want to increase graduation rates. Okay, who do you want to increase graduation rates for? Because these kids, if you don't do anything, they'll graduate anyway. Or these kids that are at the very top, they're 98% likely to graduate, you can maybe push them to 100%. Do you care about these, or do you care about the ones at the bottom? Oh, I care about the bottom who wouldn't graduate otherwise. Okay, so you want to increase the 25th percentile graduation rate, or because you have to formulate it into some sort of a mathematical metric that you can then optimize for. So these conversations often take a while, where you have to start with a very vague goal, and then you formulate the problem in a way that you can now solve if they have the data, and then help them figure out what actions do they take in order to optimize the goals that they just started with. And so one of the things we did to kind of teach people how to do that was actually ran this about a year ago, where some of the students, my students came to me and said, we want to run a hackathon for these types of problems. And I said, what about we run what I call a scope-a-thon, which is we scope problems. So we got about 10 nonprofits to come in, and government agencies, and got students to basically break up into teams. And all day, all we did was just define and scope problems. And some students were really uncomfortable. They just wanted to write code. Like, I can solve this problem. I can, put I can run this algorithm, and I can predict these things, and I can put all the results into MongoDB, and I can put a Node.js front end on it, and it's going to look great, and I can put D3, and it's going to be wonderful. Like, no. No coding. All we're going to do is define the problem, figure out what data is required to help solve that problem, what actions they will take if they had that, and then how would they communicate its impact. And so at the end of the day, each project had sort of a write-up of, here is the project scope, here's the problem formulation, you started with this, and here's what you can do to now work on solving this problem. And I think we need to refine this, but we need a lot more of those type of things where we learn and teach people how to get from a vague description to a formulated, solvable problem. Another thing that we do, which I'm not going to talk too much about that, but there are a lot of interesting research gaps right now that can be filled by sort of merging these two areas. Because right now, a lot of the machine learning world is really, typically working on prediction. So we predict, and then we watch things happen. And then we're really happy if something happens that we predicted, right? So, but we don't change anything. We just predict and predict and predict. That's caricature, but it's mostly true, right? On the social science world, we do lots of interventions, but we don't use data very much. We sort of take, mostly, we put people into groups A and B, try treatment, control, and then generally go for some average treatment effects, right? Now you can imagine there's a lot of other things. We can start doing more adaptive experiments. There's a lot more work, and a lot of it is happening. There are people in both sides who are trying to merge these two things, but we need a lot more work because a lot of the problems we talked about really require these two communities to come together and start working on these types of problems. On the education side, we also need people from these two sides to come together, right? So we have I didn't realize it was a recruiting talk. So there's a master's program that if you guys are interested in, but this is an example of sort of few universities. CMU is one that's been running a computer science, machine learning, and public policy program. We started one that's a joint program between computer science and public policy. Georgetown has a data science program that they're trying to become more policy focused, but there's more and more of that hybrid work happening where people are realizing we need policymakers, future policymakers, to be much more competent in using computers, period, and using data and understanding how to do that, and vice versa. People who are interested in technology and data and computer science need to learn how to solve real problems, and there's a whole set of problems here that we can have an impact on. The third example I'm going to give is a program which actually a couple of people here have gone through, Nihar over there and Ben over there, and I think those are the only people I saw, but there are a few other people from Harvard also who've gone through this program. It's called Data Science for Social Good. And what we do is, most of the projects I talked about basically started off as a project in this program. So what we do here is, it's a summer program where we just finished the application process. We had about 900 applications for 40 positions. It was a nightmare. We just finished accepting all the people, so sigh of relief mostly. But we get applications from basically around the country, around the world. We get a few hundred universities of people applying, mostly grad students from computer science, statistics, machine learning, econ, sociology, political science, public policy. We bring about 40 of them together to Chicago every summer. And what they do is they work on these types of projects. And the teams are made exactly to kind of cover the spectrum that I talked about, right? So you want people with all those different skills, not because they can do all separate things, but so that each of them can be exposed to everything else and work together in order to solve these problems, because right now, any single person doesn't have these problems and all these skills, right? So what we end up doing is, typically in a summer, we do 12 projects. Each team is about 3 to 4 people, and we spend the summer going through these things. So the point is that what we're learning from those programs is there is a need to train, in universities, sort of interdisciplinary or cross-disciplinary is always a buzzword. And at least our belief is that it doesn't really happen through coursework. You're not going to get the person taking these courses and that's how they get trained. It's really by working together on real things. So we really believe that training and educating is really by working on these problems. And we're finding that more and more projects, as we get, the first year, we were just figuring things out, 2 were a little bit better, third year, hopefully a little bit more better. As we're getting farther and further into these projects, where the projects are getting to the point where new challenges are coming up, right? So a lot of the challenges I talked about, we don't quite realize them until a project is moving towards the end, and now it needs to be validated in the field, right? Because all of these things, we can build models and predict things and hold that and cross-validation, but when you actually want to deploy it in the field, the final validation is getting it out there and running some sort of a trial. And that takes a lot of time and effort. So 3 months is not enough to finish any of these projects. What we end up doing is we start these projects, do some sort of a prototype proof of concept in the summer, and then some of the projects, we're trying to do more and more of these, continue after the summer and actually get to the point where they get field tested and then deployed. So that actually that's the only recruiting slide I have, is if you're interested, it's summer, so you can still stay here and do the other stuff. And then come in the summer. If you're a student and you're interested in being part of that program, apply next year. This year is too late. We also hire mentors in the summer. So if you're interested in being in Chicago, summer is wonderful, do that. And then all sorts of other things. So if you're interested in this type of stuff, come talk to me afterwards. I'm going to be around. Email me. We can connect you with organizations who are doing this work. A big one is DataKind, who connects people on different types of projects, so talk to them. If you're interested in organizations that are in the local in Boston and Cambridge area, there are a lot of ones we work with, so happy to connect you guys, happy to tell you more. But yeah, happy to take questions. Thank you. So. Yep. Yeah.
How do you decide when to kill a project?
Yeah, we kill a lot of projects. Well, so when we start, we've become sort of more and more selective over the years in the projects we do because we have limited resources. So when we start a project, typically people pitch a project to us, or we go to them and say, hey, we think we want to work with you. You guys are doing good work. Can we help? We ask them for a few different criteria. But the first one, it has to be a problem that has some aspect of social good in there. As much as hedge funds email us about how liquidity and high-speed trading is good for the world, it's a very subjective definition of social good, but we take that. That's the first bar. Second one is they need to have some data that's relevant to this problem that they can provide to us. There are examples where an organization will say, I have this problem, and can you go find some data that can help solve this problem? I've heard this open data thing is really trendy now. It turns out, most of the problems we work on, they're not open. They're not. The data is very sensitive. It's about individuals. It's about people. So the second one is really you have to have data that is important to solve that problem, and that you can give it to us. We don't disclose the data. We open source all the code, but we don't disclose the data. The third thing we look for is commitment in the summer to work with us. But the fourth one is some sort of commitment of what do you do with it afterwards. And that is something we're getting more and more selective on, is you have to have some commitment that you will take some action, whether it's validating it, whether it's implementing it or deploying it. And because most projects may not even get that far, depending on the summer, but if they do, we need to have some sort of a commitment from them that they, so if any of those things fail at any given point, the project kind of has to, we don't start them, but if the commitment changes, or the obvious one is, if the data we have is not, we build these models and they just don't work, then we have to kind of stop. But typically, every year, the first 2 years we had to kill one project every year. There was the project you guys were on, and that was an interesting one. We're working with CFPB, Consumer Finance Protection Bureau, and they were interested in helping, they were looking at, they had access to all mortgage applications in the country. And they were going to give us all that data to help them figure out something, and that's when Snowden happened. And they were being asked to go in front of the Congress to testify who they're sharing data with, and so they freaked out. We can't share data with anyone outside, we have to stop. So we had to kill that project. The next year we had a project with this company, with Feeding America, and this company called IRI that collects retail data from every retailer, basically. And they had a data breach where they had accidentally released Walgreens data on their website. And their lawyers shut down all data access for anybody outside the organization, so we had to kill that project. So we always keep some backup projects from then on. Other questions? Yeah.
Are there, sorry, are there jobs doing this kind of work, and where are they? Who pays for this?
Yeah. Very good question. Any other questions? No. So there are and there aren't. There aren't enough jobs. Well, there are more jobs than people right now, but that's true for anything to do with this, data buzzwords. But to apply them to public policy, so there are more and more, government is hiring, right? So if you're, like there's a US Digital Service, they're hiring people. The White House has positions. So at the federal level, a lot of the federal agencies are hiring for these types of positions. At the state level, again, like every state has a few positions. At the city level, more and more. Right? So Boston has been building a team for the past year or so. And then nonprofits have some, I think that the challenge they often face is they don't quite know what they're looking for. So they'll hire people, but they don't quite know how to define what they want to do. And often in smaller organizations, they hire a data person, and that person they think will do everything from something with Excel to databases to building predictive models to doing a reporting dashboard, because they can't quite distinguish. But I think most of them are getting, nonprofits are a little bit behind, but I think governments are getting further ahead because they're sort of seeing the value of doing this work. So there are jobs out there. They right now don't pay as much, but the difference is decreasing. Right? So right now, I'd say if you're finishing a PhD or you're a grad student, you're going to see about a 30% difference, which is much less than it used to be. So there, but you can then live with yourself. Because there's only so many clicks you can do on Facebook and Google. So.
I was wondering how you deal with contra-positive hypotheses, and what I mean by that is that, for example, in the loan area, some people would say, oh yeah, the maximizing goal is get more people who don't qualify to get qualified, but then the contra would be that if you get people who aren't qualified and they default, they're in a worse position than they would have been if they hadn't gotten it. So I don't know how to do that. Do you publish this?
Yeah, no, I think that's what when I was talking about transparency, it's not just the model transparency, is putting out the entire solution as opposed to just the positive things, right? So here, you're basically looking at, you've got, it's a confusion matrix, right? So your true positives, your false positive, your true negatives, your false negatives, and then you've got a cost and a benefit for each of those cells. So you could use that to figure out, okay, here's the cost for this person. If I'm wrong, I'm going to be wrong in 20% of the people. Can I go deeper and say, how wrong am I going to be, and what's the impact on those people? And then you're deciding at that stage. Now the problem is, you have to design some sort of a policy to do that. And that policy, as much as you can use sort of individual level data, it can be more personalized, but you're still going to have some negative effects. So the question becomes, what's the risk tolerance you have? Do you want to minimize the average risk or the average cost, or do you want to maximize, you want to sort of maximize the number of people you help, right? So, and those are all things that I don't have an answer, like what the right thing to do is, but I think right now, most of these policymakers are not making a decision that way. And so the idea is that if I give them these tools and I make it very obvious, and not just very obvious, but very auditable and transparent. So when they make a decision, they know its impact. So later on, there's no, well, I did this thing, there was my hope, and here's what happened. At least there's more evidence-based transparency here. So I don't know which the right thing to do is, but I think that's a decision you want to make sure that not only the policymakers know what's behind it, but also everybody else knows the decision they made and what information they had. And so I think that's why transparency is much more important in these types of problems than it is in a lot of other problems that we deal with. So, okay.
I think we're just to remind the students that we don't have all these problems in Boston with lead.
You've got lots of other problems. Thank you. Thanks.